looks like things are tapering off. People slowing down to a mere trickle coming in. I think we'll go ahead and get started today. Welcome everybody to my talk, Designing a RESTful API Using Spring 3. My name is Ben Hale. I am a long time SpringSource employee, now VMware employee, and we're going to talk a bit today not only about designing a RESTful API, we're also going to talk about what it takes to implement that API, and then the thing that we all love to do, obviously, test one of these RESTful APIs as well. You know, this is a couple of things that people don't think about a lot. And I've been looking at this room every single session that I come into here, every single session that I'm not here but walking by or something like that. This room's pretty intimidating, right? Every time. It's completely chock full. People, you know, sitting in chairs out in the hallways trying to find out what's going on in here. And so I'm actually heartened to see so many people in here for my talk, because it has one big difference than everybody else's that have been in here. I'm not really talking about the client side at all, right? We're going to do a little bit of that, but this is all about server-side development, right? A little bit less sexy, but it turns out, you know, really important. So we'll go ahead and get started by talking about what REST is to start with, right? Everybody's heard the term REST. Everybody's here because they know REST is important, but what is REST really? And so REST ostensibly stands for representational state transfer, and really what we're talking about here is an architectural style for developing distributed applications. So we're not talking about a spec. We're not talking about a standard or anything like that. We're talking about something very stylistic. There are certain things that you might say, you know, this is definitely not the right style, but it's very difficult to say this is exactly what the style is, right? We talk more in the terms of constraints when we talk about REST. We talk about the fact that a REST API should be sort of client-server, right? Something we all know about, clients talking to server. We talk about how that communication should be stateless, right? Everything that you need to know to execute some sort of REST behavior needs to be included inside of a REST call. And we also talk about a uniform interface, okay? There are more constraints in this. You know, I encourage you to check out the Wikipedia page on REST and find out more if you want to know about them. But the things that we're talking about today are going to be primarily around HTTP. So HTTP itself, REST itself is not tied to the HTTP spec, but there's an awful lot of overlap. It's most commonly associated with it because Roy Fielding, one of the authors of the HTTP spec, was also the guy who coined the term REST and described what a REST interface actually was. Chapter 6, I believe, of his doctoral dissertation, and as these things go, quite readable. If you really want to get a good in-depth understanding of what he had in mind and the reasons that it's not necessarily tied to HTTP. However, because we're all here, we're all doing web development, HTTP is what we're here to talk about, right? So we know client-server in the context of HTTP. That makes, you know, pretty straight sense. We know the idea of statelessness as well from the development that we do on a daily basis. We know what it means that we don't want to maintain all of this state on both ends of our transaction, right, or of our communication. We want to basically be able to say, just do this, and I'll maintain, you know, my own internal models on either side. But what about this uniform interface? When we talk about uniform interfaces with HTTP, once again, we're talking about flexible principles, right? We're talking about things like we need to be able to identify a resource. How are we going to do that with HTTP? We need to be able to manipulate those resources, the representation of those resources. How do we do that with HTTP? We want to make sure that the messages that we're actually using when we're doing these things, when we're manipulating these identified resources, are self-describing. And then there's this big long thing right here at the end, hypermedia as the engine of application state. And this is one that's sort of where a lot of REST has broken down previously, but we're seeing a big resurgence. So the HTTP uniform interface is pretty simple, and it was certainly designed to be very simple, right? URIs identify resources. They don't have to be a unique identifier for a resource. It's just a way to say, I want to do this to you, right? I am talking about exactly the thing that I want to answer my request. We have URIs that do that in HTTP. We also have a very, very small set, a very limited set of HTTP verbs that are used to manipulate these resources that we've identified with URIs. We're going to take a look at the big four of them in depth in the next couple of slides, but get, delete, put, and post, ones that almost everybody's heard of. Obviously, until recently, for all intents and purposes on the web, it was get and post. The other ones have always been there. We just haven't been using them because browsers didn't really support them. But as we start talking about these new mechanisms for accessing HTTP, whether it be from a native application or using XML HTTP request or something like that, some of these other verbs have certainly gotten to be more and more prominent. There are a couple more beyond these four, obviously, things like head and options and things like that. They're less often used, but I don't think they're necessarily less important. In the context of what the API we're going to design today, we're going to skip over them a bit, but definitely know that they're there and have a place in the concept of HTTP. And then finally, we talked about that idea of all messages being self-describing. So HTTP uses headers to do this. So for example, you have content type headers and accept headers, and it helps clients and servers know exactly what they're getting back. They're going to get back this hunk of bytes, but what do they do with it, right? All these messages need to be able to tell the consumer of that message exactly what to do with bytes that they've gotten. So the first verb that we're talking about is probably the one that's most common, certainly the one that's most familiar and most understandable to people, get, right? It's a way that we retrieve information about a resource. It's supposed to be safe and idempotent, so to address the idempotent part of it, it means that if I call get 1,000 times, it should behave in exactly the same way as if I had called it once, right? And a lot of times, people will say that get shouldn't have side effects, and that's absolutely true, but if you actually read the spec on it, it says side effects are actually okay in limited cases, right? So one of the classic examples here are, if I can have a side effect if the client sort of doesn't expect it to happen and it's not important to the client that it's happened. When I say, get me this list of jobs or something like that, if I needed to, for example, create a new resource somewhere else that was an audit log entry, that's okay, because it doesn't actually impede actually affect the way my request is handled or information I need to further my request from there. Now, in practice, you want to minimize as much as possible the side effects, right? You want to make sure that, for all intents and purposes, when somebody calls get, it just retrieves a piece of information. But it isn't really a hard and fast rule, and we're going to keep seeing things like this when we talk about REST. At lunch today, I was a little bit nervous. It's the first time I've given a talk about REST. It's something that I'm pretty familiar with on a day-to-day basis as part of my job, but I was worried, you're going to stand up here and talk about REST, and it's something that a lot of people are doing, and a lot of people have opinions, and some opinions are good opinions, some are good opinions are bad opinions, but since REST isn't really a set of standards or a spec or anything like that, there's no wrong answer, right? Anything that's sort of defensible, yeah, why not? Anything goes, right? It's sort of a continuum of rightness, if you will. So get also has a couple of cool little things inside of HTTP in that it can be conditional or partial, right? So fundamentally, if I call get, get this list of jobs, and I want to call it again later, it may be huge, a meg of XML needs to be transferred over to me. And in an ideal world where there's no latency on networks and there's no, delay getting this information, no cost to the bandwidth or anything like that, that might be fine. But the reality of the situation intrudes, and so get can be things like conditional, or it can be partial. So we can say, only send me the data. So I'm going to request some data from you. Only send it to me if it's been modified since the last time, for example, that I asked for it. So it's really, really powerful in that way, in that you can sort of see how these verbs were designed, especially get in this case, for the best case scenario, just call get all the time. But also sort of has acquiesces to the reality of the situation. It's sort of this flexibility that allows you to do things like only send me the data, so minimize my cost and my delay and things like that. And so in general, when we're talking about HTTP requests, we see get/games/1, something like that. Really, really simple and straightforward. The next simple one, I'm putting the sort of complicated and controversial ones at the end here, is the delete verb. Delete is exactly what you think it is, right? Request that a resource be removed. Where I see people making mistakes with delete, however, is it doesn't actually mean, when that command returns, it doesn't actually, or that request I should say returns, it doesn't actually mean that the resource has necessarily been deleted. Deletes may be a long-running process, right? If you told me to, delete something that was backed in a database, I need to delete an entire, table off a database or something like that, do some sort of cleanup, remove a bunch of files off of a file system, something that could take a long time. It's not necessary that delete block open a socket, right? Keep an HTTP connection open until it's done. You could instead say, okay, I accept the request that you've given me. I'll tell you that I'm going to do it. And I might say, here's how to find out how far along I am in the process or whether I'm complete or not. Return that information as well. And then eventually the delete will happen, right? So delete isn't as instantaneous as many people believe. And it's certainly reasonable for delete to take a while and without keeping a socket open. So now we have the put verb. And the put verb, misunderstood, probably, I'd guess, the least used of the HTTP verbs that are out there. And it fundamentally requests that the entity that I send as part of the body of this particular request be stored at a particular URI. Certainly there's some controversy whether or not it needs to be the entire body of it or not. But fundamentally what we're saying is, so for example, if we've got some doors, I think you guys can see what demo I'm getting ready to do this afternoon. I want to say this door needs to be created and it should have a status of selected, but not just created, right? If this entity already exists, what we're basically saying is overwrite the existing entities that's there, or overwrite partially the entities that's there, and say that if a door exists, I want to modify what that door is, in this case what the status is. So we can use it to modify. I'd say that's probably much more common than the create, simply because create would fundamentally allow someone to select the ID of the new entity. If that door didn't exist and I got to pick it, who knows, it might overlap with something else. It might not necessarily be in the ID scheme that I want. It's certainly possible to do, but it's not something that's commonly done. We typically see puts as a way of mutating rather than a way of creating. And then the final verb we're going to talk about today, post. And the post here sort of goes at the end because this is sort of a catch-all. If none of the other verbs sort of do what you want them to do, post is basically a way of saying do something, right? It's not necessarily mutable, so you might post to a particular URL if you wanted some long-running task to happen, right? If you want to send an SMS or if you want to start a batch job or something like that. It doesn't sort of have an analog to the idea of putting something and mutating the entity that you eventually get back. You could create, you could modify. Create is probably the most common place that we see post here. And the reason that is because the difference between put and post is fundamentally what URI or what resource is supposed to do the work you're asking, right? When you take a look at put, you're actually posting to a particular resource's URI something about that particular resource. Act on yourself. When you talk about post, maybe they're acting on themselves, but it's not necessarily required, right? You could potentially post to /games with some information that might, for example, modify a door. That's plausible, right? Or you might post to /games something that creates an entity /games/0, right? So post is sort of the catch-all at the end that allows you to do pretty much anything you want. Yeah, absolutely. What do you do for actions? Well, hold on 1 second so that I can give you this, right? 3 doors. Everybody remembers this from dinner last night or after dinner last night? Let's make a deal. You get to select a door. The host opens a door to show the small furry animal. My small furry animal is a little different than Adrian's small furry animal. It's my cat Loki, and with a name like that, I'm sure the demos are just going to be absolutely flawless, right? No problems there. They've opened door number 1. We do the mathematically correct thing, and we get to choose which door to open, and we've won Jurgen, right? So this is what we're basically going to be talking. The REST API that we're going to design, implement, and test. I haven't forgotten. So if we take a look at the interaction model, and this is where REST API design really comes in. how are people really going to use your API? In some cases, you can't know, right? You throw this API out there that exposes all of your data and stuff and tell people, do whatever you want, right? Do whatever you want. Here's all the data. Here's some actions that you might be able to do with it. And that's certainly a perfectly reasonable way to design an API. But a better way, in the cases where you are really sit down and think about how users are going to interact. Because our model basically could expose, everything, all doors, all games, a bunch of different operations you might want to do on it. But realistically, using this API works in a very, very specific way. They create a game. You list all the state of all the doors so that we can say, okay, they're all closed, right? The user then needs to tell us the door that they have selected, mark that as selected, open a different door that doesn't have Jurgen behind it, and then return that to the user, and then allow the user to open one more door, list the outcome of the game, and delete the game, right? So when we take a look at that, and you try and map that to get, put, post, delete, some of them maybe work. List the current state of all the doors is probably going to be a get. Delete the game is probably going to be a delete. We know creating a game, probably going to be a post based on what we've seen so far. But how do you select? There's no HTTP verb for select. And this gets back to your question. How do you execute an action? And there's a lot of bad REST. But again, there is no wrong REST. Remember that. Because this is fundamentally the problem. How do you do an arbitrary set of actions with a very limited set of verbs? And so we're going to explore a little bit about what it takes to do this. So, creating a game. The first thing that we need to do, we're going to explore every single step that we just saw in the interaction model, and we're going to sort of put down what we expect sort of down here at the bottom, what the URI scheme should look like. From a REST perspective, we're going to talk a little bit about that whole hypermedia blah, blah, blah. I'm just going to sort of skip over it for the moment because we'll talk about it in a bit more depth later on. In REST and specifically sort of as you dive into it, you find out that much like a normal programming API, the best way to design an API is to have a very, very limited number of entry points. Very simple, very well known. This is what you get started. It means that you don't have to describe every single endpoint that your user might ever need to get up front. Lock it into, for example, WSDL or something like that, so it's a huge pain in the ass to change. This is not a really good way. It's not particularly flexible. And so we want to make sure that, based on our user interaction model, that we have a single simple endpoint, well known, right? We know when it comes to creating a game, we don't need any particular information in ours. Maybe, you are designing an API that takes some sort of input, username, the number of doors you actually want to play with, something like that. And the key here is we also need to return a resource identifier of the newly created game. We're going to talk about how that's done sort of in HTTP and REST. So pretty simple. We need to post to games. That's the first API that we'll design and that we'll need to implement later on. Yeah? Sorry, can you speak up just a little bit? Yeah, so the question is, why have I chosen games instead of game, the plural instead of the singular? Purely stylistic. I'm sure someone in the REST community would tell you this is exactly why you should choose one, and I'm sure you'd talk to the guy right next to him and say this is exactly why you should choose the other. Stylistically, for me, it represents a collection of games, right? It's a collection here. When I put a /1 on the end of it, it specifies an individual one. I don't think it matters, really. We're going to see later on, if this is the only URI they know, who cares, really, right? I am a special kind of OCD, and so when I design REST APIs, you look at them, you read them, they are absolutely phenomenally pretty, incredibly understandable, because that's the way I want them to be, and they see one URI. No one ever sees anything else, right? So a lot of it doesn't matter a whole lot. I've chosen plurals because I certainly prefer plurals, and it sort of works logically in my head. Anybody here have any preferences? How many people like plurals in their APIs like that? And anybody singular?
Yeah, I mean, it depends. Like, for example, accounts versus accounts is where you get multiple versus.
Sure, yeah. So, It completely depends on how your sort of logical understanding of your API goes, right? I'm heartened to see that by about 2/3, I'm in the majority here. So, but none of the rest of you are wrong. Remember that. Nobody's wrong in here. Yeah, question again.
There's a bigger schism between words and nouns.
Yes, definitely between verbs and nouns. So what you will notice is there will always be exactly one verb in my URLs and a whole bunch of nouns to follow, right? They're called HTTP verbs for a reason. That is where the verbs are. All the operations, all the behavior that you can do via HTTP is well defined in a set of HTTP verbs. You need to use those verbs and use better words to do all of these other things that you might want to do, right? And so that's where one more slide before that one. So we list the current state of all the doors. Needs to return us one big collection that represents the state of all the doors in the game. Doesn't need to be particularly complicated in this case. So Adrian and I sat together around a whiteboard, and for the better part of 2 hours, I think, we sort of took what should have been a really, really trivial game, right? Let's Make a Deal is not the conceptually hardest thing in the world, and tried to design what this API was going to look like. And that's not uncommon, right? The first design that we had literally door 1 equals, door 2 equals, door 3 equals. And maybe logically that made a lot of sense in the beginning, but it didn't have to be there, right? We're going to find out a little bit later on, each door can be uniquely identified. And we know that there are 3 doors. So why do you need to have a door 1, door 2, door 3? As long as you're saying, I want to open door X, door Y, or door Z, we're good to go, right? So think about that when you're designing payloads especially, is how much information do you actually need? Beyond the whether I am going to send a whole lot of bytes or a few bytes or what I can optimize out here, conceptually, every sort of more specific thing that you're putting in, every sort of unique identifier sort of weighs things down, right? If it's sufficient to have simply an array of door objects that can all be uniquely identified, go with that. Go with something very simple rather than something that says door 1 equals this, door 2 equals this, and have 3 separate properties for it. It's just a little bit easier to get around in. Yeah?
I mean, we follow a pattern like this, doors, you give all the doors are similar. If you want a particular door, just door slash.
Yep. Yeah, it sounds like what you guys do is you basically have like a /doors and then you have a /door/1, right? So you don't go through the plural to get to the individual, in other words.
Like, do doors,
Yeah.
the list, but if you do door /number,
Yeah.
just get that.
Yep, absolutely. What you're going to find out, though, in this particular design, so he was saying, you have /doors to get them all, /door/1 gets you an individual door. If you remember back to the interaction model slide, never once did we say you needed to get the state of an individual door. User never needs that information. They need to know what all the doors are, right? Because at the beginning, they need to know what they all are. And when they choose select, because a change is going to happen behind the scenes, they actually have to poll for all of those doors again. So we're never going to design a /doors/1 API as part of this. You could put it in. It'd probably be trivial to put it in. But it's another endpoint. It's another support point. It's another legacy piece of API that if you ever wanted to change, it's going to be a huge pain in the ass. So minimal. This is where understanding your user interaction model is really, really critical, because the smaller sort of surface area you've got, the more dynamic and the ability to change your stuff is there. So now we get to talk about that horrible thing, select. There's no HTTP verb select, although people are sort of making new HTTP verbs, that patch verb and stuff like that. They're coming out of the woodwork, right? So how do we represent the selection of a door using a very, very limited set of HTTP verbs? And there's a number of different ways to do this. I'm sure we have all seen REST examples that have like a /edit in them and stuff like that. But you don't have to do that, really. If you design an entity in such a way that it can represent its current state, or whatever this modification you're trying to do is, you can simply put a modification to that state, right? So in this case, we have a door has a status, and it's closed, selected, open, right? And by default, if we had an API for it, we could pull it, and it tells me by default that status is closed. or selecting or opening, we're going to see on the next slide, is simply changing that status, right? So you can simply put what you want the status to be. I'm saying entity, you entity, change in this way, become this by the end of it. I'll either get sort of a successful response back saying, yes, I was able to make that change, I was able to select this door, or instead it'll kick me back something and say, no, I was not able to select this door. You're not allowed to select this door because it's already open or something like that. So you've done something as complex as a select, or as we see on the next slide, something as complex as an open. In this case, we can even reuse the API that we had defined a little bit earlier by basically sitting down and saying, I want you to be open instead of closed right now, right? So does that make sense? Yeah.
This is quite correct here, right? This is sort of looks binary for the most part. Let's say I want to run somewhere. I'm in the process of running, but then I may stop, I may restart. So how do you're essentially putting a whole state model as a...
Right, but think about it. So the state model you said, so you basically have something that is, let's say it's in a stopped state most of the time, and you want to be able to start it, you want to be able to pause it, you want to be able to restart it later on, right? So absolutely, the product I work on a day-to-day basis called vFabric Administration Server, I think is what it's called today. We do this. How do you start TC Server? How do you start Tomcat for all intents and purposes? How do you stop Tomcat? And the way is we have a /status, or no, sorry, /state URI, and in it, it has this current status. And most of the time it's in stopped. And when we want to start a TC server, we say, I want your status to be started. And interestingly, what happens is, because this is sort of a long-running process, if you sort of hold back at it, it would go from stopped to starting to started. And then when we want to stop it, we say, I want you to be stopped. So you're telling it where you want to eventually get to, right? So, and this is why I say you can do everything you want to, you just have to change the words that you're trying to say, right? Rather than say, I want to start you, you say, I want you to be started. And so that's what it is. Even something such as editing, which is the canonical example of how not really to do REST. Having a /edit isn't necessary. You just say, get me what you've got, have the user edit it on their screen however they want to do it, and then post back, this is what I want you to look at when it's over, right? Yeah.
Stretch this for a little bit more. Let's start talking about vFabric. Let's say I have a high availability system, and I want to switch from a primary to a backup. The state that I'm trying to execute on one would impact the other.
Absolutely. That's perfectly reasonable because you are talking about the state of a particular entity. I want you to stop. That may have a side effect. And the side effect may be that if we were polling over against the backup, it goes from stopped to started. Because you are operating on one particular resource doesn't necessarily preclude other resources from changing in some way. Get's not supposed to, ideally. But all the rest of them, it's free fire zone. You can do anything you want, really. Yeah. See another one over here? Yeah.
Why would you put the status where you want it to be in the body versus putting it as a query parameter?
Yeah, so, right. So the question is, why is the status here, in the body instead of as a query parameter? And fundamentally, because what I am saying with put is, I want you to be like this. Remember, if we go back to the slide where you're talking about what the put verb means, it's you resource look like this. The entity body should look like this instead of I want to gather some sort of information and here's some sort of things that will help you determine what that information is going to be. So sort of the canonical simple example of query parameters is limiting the width of a log that you're going to get, right? The middle 100 lines or something like that. Because that's not me saying I want you to be like this. It's here's some information about what some additional request information, right? And this is not additional request information. This is be like this instead. Yeah, it's a really good question. Yeah, in the back. What was the design reason for using a put instead of what? Instead of a get. Because fundamentally, I'm not asking you what your current state is. I'm telling you what your state should be. So get is give me some information. Put is be this. Okay. Same thing is true with the select, right? I need to tell the server that this door is now selected fundamentally because I don't want the host to open it, right? So I am basically changing the state of that door where the door was closed before. The door is now selected. I'm not asking you what the state of the door is. I'm telling you what the state should be. Nope, the list is a get. I realize now that this is a little bit lower. No worries. Okay. Finally, list the final state of the game, which was the next thing in our user interaction model, get. We're going to get back some information, status 1. And then we'll do a destroy just because I like to be, remember my OCD tendency, like everything to be cleaned up at the end of the game kind of thing. Don't want those sort of hanging around later on. And I want to demonstrate the use of delete primarily. So, shall we do some code? I had another moment where I talked to a couple people at the table. I said, I feel like a fraud. Everything I'm going to show is just like Spring MVC. It's taking a step beyond, if you're sort of, your canonical web developer, it might be taking a step beyond what you normally do. But it's not, it's not new stuff, right? So let's see. Don't be surprised if you all are like, oh yeah, I know exactly how to do that. I'm sure I could do that. Why am I here? Yeah. So we'll start with a standard controller, as we see here. What we're going to see is primarily partial implementations. We're just going to fill some stuff out. Like I said, it turns out that this game is a bit more complicated than you had expected it to be. Getting beyond all of the math that says you should always choose the other door when you're at the end. So we're going to mark this as a Spring MVC controller, and we're going to say that there is a request mapping. So everything in here will sort of exist under the games URI. Okay. So the first URI that we needed to implement was we wanted to be able to create a game. So we'll return a response entity. I noticed it's interesting. I live sort of over in the UK working on commercial products rather than the open source realm. And as I've sat through all these sessions with, other Spring Source employees, and especially the ones that all sort of work together in the Spring stuff, I've noticed they've all returned HTTP entity, which nominally, if you take a look at its Java docs, could be a request or a response. I don't know why stylistically they've all chosen to do that rather than returning response entity, which is what they're all returning anyway. So the response entity, as we said, it needs to return the location URI for the game that we're actually creating, but it doesn't really need a body. So the response entity, we're going to go ahead and make that void. We'll say create game, and we're going to do some stuff afterwards. So let's take a look at the request mapping for here. All the URIs that we designed before had two components, right? They had a verb and a set of nouns, basically, following it that were the path. Yeah. Sorry, what was that? Oh, scroll the code up. Sorry. Yeah, how about that? There we go. So we have this verb and we have these nouns. So we'll start by saying the method should be request method. And anybody remember what the request method was supposed to be for this? Post, right? So we're going to create something. Now, the default for value is this, right? So it's somewhat optional. From a stylistic perspective, I like to be able to read my request mapping and know exactly what I'm going to do, right? Post some URI, even if it's empty. So that's what we see. Now we'll go ahead and create a game. Game repository.create. And we're going to respond status. We're going to say, okay, that worked successfully. Now this is where things start getting dicey. So while we're waiting for that to start up, we're going to be using REST shell, which, again, remember I'm sort of out of touch with large portions of the company. I knew it existed and had never seen it before last night in the demos. And as a testament to how good this is, I basically took 30 minutes and totally sort of reworked how I was going to do this so I could do it with REST shell. And the main reason for that is, if you take a look here, I've got this thing. I've got 3 REST tools there. I also have the REST console that's put in inside of Chrome. Each one of them has pluses. Each one of them has minuses. I was going to have to use all 4 of them to demonstrate properly to you what I actually wanted to show you. And I don't have to use any of them now because REST shell works that good. That well, I should say, sorry. base URI. I tried to use control space there. That's just not going to work here. Localhost 8080. What did I call it? Let's make a deal. So if everything worked right, I should simply be able to say post. And it did, 200, okay. But this is problematic. I want to do some stuff with that game, right? What was the game? Anybody know? What URL do I use? Yeah, who knows? So, how do we do that? How do we set the location header? HTTP headers, a Spring type, one of the really cool things that you can use just sort of a generic map, but one of the really cool things I like about this is location is such an important header. You can just say set location. I'm going to cheat here. We're going to talk about the library that I'm using a little bit later, but I can sort of say link to, and I can say link to, and it asks me for a controller. So it basically asks me for a Spring controller so it can sort of work out what the URL, the beginning of the URL I'm looking for is. And so it'll be this games controller. /, and it's asking me for, let's say, game.getID. So it's basically blah, 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 /games/ID. And then we need to say that I want a URI out of that. Put those headers in here. I see Adrian over here in the audience, in fact, and I'm sure he's screaming to himself, no, we have a tool so you don't have to restart Tomcat to do this, and I just ran out of time. So let's try this again. We'll go ahead and post that /games, and look what we have now. I can't really scroll it up, unfortunately. We have a location header that has this /games, and I'm going to demo something that, for reasons escaping understanding, failed last night. One of the cool things about this REST shell thing is you can do a post follow true, and it knows that location is a useful URL, and so it will, did it do it? Did I just screw that up, Andy? Follow true. I swear this worked earlier today. Well, I must have screwed this up. That was working earlier today. It will actually change to the proper URL. Yeah. Man, I thought I did this an hour ago and that worked. Well, okay, eventually that will work. I'm sure it's us and not them. I'm sure I'm not sending the right code or something like that. Anyway, not particularly important for this. Okay, so we've created a game. And now if we remember, the next thing that we needed to do was we basically want to show some information about that game. Actually, that goes at the end, doesn't it? Well, we'll take care of it here since it's sort of alphabetically along. So we want to show the current state, whether we've won, lost, whether it's awaiting, whether it's sort of awaiting another selection or something like that. So this time, we'll go ahead and we'll have a response entity. This response entity, we're going to return a game this time. And to know which game that we actually want to see, we're going to have a path variable, long, and that's the game ID. Okay, so let's take a look at this request mapping. Anybody remember what request method we're looking for this time? Get, yeah. So again, get is the default. You don't have to put it in here. For me, stylistically, I want to be able to read it the same way I read my HTTP line. The value would be /game ID. And if you guys haven't experienced this, the curly braces basically will, thanks to Spring, will just map down into it. Yeah.
Good programming practice to use a key generated by some system. What is the URL, or is it better to have the user label a game so that you can use that instead?
Yeah, the question is whether it's better practice to basically use a synthetic key or a natural key is the question. And the answer is I don't think it particularly matters. It's got to be certainly something that's, you know, a true key. So if you can enforce that your users are creating these things and they are keyed, sure, why not go ahead and use them? It turns out in many cases most people have access to, you know, synthetic keys simply because, you know, they're used in the database or whatever, you know, backing store there is. I don't think it matters a whole lot. And fundamentally, when we get to sort of the hypermedia bit, no one's ever going to see this URL ever again, right? So. Yeah.
Just for this question, if you use a gig for key, then they will be posted with a key, which is not right.
So the question is, you know, if somehow we had a user-generated key, it sort of implies that they had posted with a key. Your URL space could take a put to that particular URI with the key on it. That's one option. The other thing is passing in that key, but as part of a posted payload. So you got a JSON payload and it says key this value, key this value this, whatever kind of thing. You could use one of those as the key potentially, and that would be okay in the case of a post as well. So one of the things, and this is where I think we start stepping into the bit that a lot of people who use Spring MVC don't really realize these features are here, is you can actually define what this will produce. Produces. And it takes a set of strings. So Spring handily provides media types for us. So we're going to say application JSON value. And this basically tells a whole lot of infrastructure inside of Spring that what we're going to hand back is a piece of JSON. And one of the really nice things that this does is we get some automatic type conversion. So it will, for example, take our game object that we've got here, serialize it using Jackson into JSON, and send that along. It'll set some content type headers as well, for example. So this guy, game goes to this dot. Retrieve game ID. We'll return that response entity. This time we are going to hand something back. We're going to hand back the game and another status code saying, yeah, this worked okay. Now you'll notice this has some exceptions. We're going to talk about those a little bit later. In this case, what happens if you request a game that doesn't actually exist? What do I do with my server here? I'm going to try it again. I just cannot believe this doesn't work right now for me. Damn it. Okay, so we have a location, so we can follow 0. Look at that. Yeah. We got our automatic type conversion, so we see that there is a status awaiting initial selection way down there at the bottom. Sorry, you guys in the back. An ID at the top, doors with all of their current status. It's questionable whether you want to send all of this information, notably the IDs for these things, since the IDs are in the URIs, and they're totally useless to you, really. You can't actually ever do anything with them. But we'll discuss a little bit later. Internally you need access to this ID, but you don't necessarily need it. Your customers don't need it. So what strategies do we sort of have around making sure that that stuff gets hidden? The next thing that we're going to do is the modifications. I hear a question? Yeah.
So you mentioned about the JSON marshalling.
Yeah.
You slipped in a quick Jax there.
Jackson.
What's that?
Jackson. Jackson. Jackson.
Okay, so not like JaxB.
No. Jackson is, sort of, at this point, I think, the de facto way to serialize Java objects into JSON. It's got a nice annotation model so that you can just take your domain models and say what should be there, what shouldn't be there. It's got the ability to both serialize and deserialize. You can use, if you're sort of like me, I love completely immutable objects, so really complex constructors rather than setters and stuff like that, and it can instantiate them through constructor injection fundamentally as well, all that kind of stuff. Really, really good stuff. Yeah, Jackson. What's that? I'm sorry, I still can't hear. Oh, what was returned? Oh, okay. Yeah. What do we do? Show game here, right? This guy here. So we put this produces stuff up here, basically saying this is what this method expects to produce. We're going to see a little bit later on that it can produce more than one thing. No, it doesn't. So the question is, when I say produces media type application JSON, so basically I'm going to hand back a content type of JSON, does that bypass what's in the accept headers? No, it doesn't. So if you request from me XML and I tell you all I can do is JSON, we say, anybody know what it is? 406 maybe, something, conflict I think, or no, not conflict, not acceptable I think is what it is, yeah. Not acceptable goes back and says, sorry, I can't produce what you need me to produce kind of thing. If you take a look at the spec around that, there's some wishy-washy language at the end and says, if they won't accept anything that you're going to hand back, you should hand back something anyway, kind of thing. I don't know about that. The odds that you're going to run into that these days are pretty low. Most people, you're going to know whether you want XML or JSON, and you'll be able to hand both of those back pretty easily. So let's take a quick look at the interesting thing, the door modification. Response entity, again, modify door at path variable, long game ID. Door ID, right. We need to know what else, or what door we actually want to work on. We're actually also going to need a body this time, right? Something is going to be posted to us. It's going to tell us exactly what status we want this door to be in, right? In this case, we'll use response body. I am going to actually tell it that I want a map of string. Jackson, in this case, is going to take basically the bytes that come in. They're going to be a JSON payload, and we'll map it back to a map for us. However, it can be much more complex than that. If I put a rich type in place, and if you take a look at Adrian's code, he's actually done this. It will actually map back to a rich type. Yeah, question up here? No? Okay, cool, yeah. Yeah. I misspelled that, didn't I? Response body. Wow. All right, sorry. Yeah, sorry. Thank you. My typing abilities are just totally breaking down now. Request mapping. So it's going to be a what this time? Anybody know? What's the method? What do I hear? Put. Yeah, we're going to go for put. Post is reasonable. Don't really get involved in anybody who's particularly dogmatic about these things. We're going to go post, or sorry, we're going to go put for this time. I equals / game ID / doors / door ID. Right. An equivalent that I need to spell properly. Consumes. What do we want? Media type. Application JSON again. Okay, so this basically is saying we are effectively only going to accept application JSON for this, get good deserialization again. To do the actual work, door status. I've got a little helper method that gets the current door status for me. Going to go ahead and get the game. Let's see if I can remember how the rest of this is going to go. And we said, remember, this URI can be used to do a couple of different things. And this is sort of solving the impedance mismatch between what is our externally facing, very simple design for the way the user wants to use it API and what we have on our back end, because we're going to find out that there are actually separate methods for selecting and opening doors in our service layer, but we don't want to expose that to the user. If it's selected, game dot select door ID. Else. I'm taking a shortcut here. Don't just do else like that, obviously. Open yourself up into all sorts of world of hurt there. A bunch of different things. What happens if you've given me a payload that doesn't actually have a status key inside it? What happens if you've asked for a game that does not exist? What happens if you're trying to transition a door that can't be transitioned in the way you've asked? What happens if the door doesn't exist? All things that you sort of have to handle. But if everything goes right, response entity. I've been doing a lot of Python lately, so I've forgotten how the new keyword works. And we should be able to get something now, I think.
So I have a quick question.
Sure.
Just stylistically.
Yeah.
So using this sort of method where you're flipping value
Mm-hmm.
in order to run a verb.
Mm-hmm.
From
put was an update.
Yeah.
How do you describe that my API, this update really is an action depending on what field you modify?
You can't get away without documentation, right? Although in the particular, so sorry, let me go back. And the question was sort of, how do you impart to users that when you put a particular value, it's not actually updating the value, it's actually implying a transition of some kind, right? And so don't anybody think that you can get away without documentation. If we have a little bit of time at the end, I'll sort of show you the documentation we use for VAS that is, as long as your arm for each individual method, describing exactly how it works. I mean, equivalently, you need JavaDoc for all of these things, so people can understand. It is still a contract. It's a much more informal way of defining a contract, but it's still a contract, still an API. In your particular question about it, I don't think you should tell them that in some cases it's starting and stopping, in other cases it's just changing the value of property. Fundamentally, you're changing the value of a property. The way that is done, whether that is changing a string in memory, flipping a bit somewhere, or starting a server, isn't particularly important. If you sort of look at the representation of a resource as an abstraction, right, or as I say, as a representation of a resource rather than the resource itself, it means that fundamentally there's a layer of abstraction beyond which your user doesn't need to know what actually happened, right? I mean, if you wanted to, I could change, a value from 1 to 2, and what I did was I put that into a thread and told to go to sleep for 30 minutes. Right? And then it eventually changes. It's fundamentally the same thing whether you're starting TC server or just changing a property. So we'll go up, post, follow 0. We'll do a get. We got some doors. I happen to know that if we follow doors /1, and we'll go ahead and do a put. And it's data. There is actually something, I'm sure this is actually a bug. The way you actually define data is pretty crazy. Yeah, because there's your quotes sort of unescape one another and aren't required in places where they are and stuff like that. I'm sure that will be fixed forthwith. Yeah, so based on my reading there, status at the end isn't in a quote, but I think this works. No, it doesn't. What did I do? Because it's not status, is it now? It's selected. 200, okay. So now I'll bet you if we sort of go up, and we say get again, we see that a small furry animal has been revealed behind 3. We have selected 1. Have we selected 1? Yes. And 2 is unknown. So we might go back down to... was that what I want? Yeah, doors 2. I think we can selected. Is it opened? No. Is it open? Yes. And we'll get. And it appears that we've won. We've gotten Jurgen. Congratulations, everybody. Yeah. Give yourself a round of applause. Yeah, in the back. Yeah. Yep. Yeah, so suppose instead of games 0, we went to games follow 42. Get. Boom. It's a whole lot of HTML. For those of you who spend too much time in REST, you'll recognize that as the HTML page that Tomcat kicks out. Totally useless, right, to every single REST client you will ever write. Hell, it can't even fit on this page. So what do we do? So thank you for leading me directly into the next set of slides. So the answer is, what we do is status codes, right? We've talked about verbs, we've talked about paths and things like that, but there's more to HTTP requests, and this is the thing that I think most people forget. We've seen, we sort of did created, we sort of did okay, everybody sort of knows those. But there's a lot more than that out there, and status codes are great in that they are a first line of information that can be given to your consumers about what has happened, whether good or bad. But then they can also be augmented with more detailed information. So we see there are a couple of groups broadly defined. 100s are informationals, 2s are successes, 3s are redirections, 4s are client errors, 5s are server errors. There's an I'm a little teapot in there somewhere as well. 200, everything worked. The one you always want to see. 201 created. Server has created a new resource. It is required by spec, I'm pretty sure, that if you create something, you have to return a location header that sort of has some way for you to find what was actually created. 202 accepted. Remember I told you a little bit earlier about delete may take a while, right? I use the term accepted, although I'm sure not many of you really picked up on that. But what you say is, I have accepted your request. It's not yet complete, but I can't keep this connection open, right? It's a huge denial of service hole there. And optionally, you might return a location saying, go check over here, right? Here's where you can find the status of this particular operation or this particular task. We use this certainly in VAS to great effect, nearly every single thing in our API, because you roughly talk to a server and then we talk to 1,000 servers on your behalf kind of thing. It takes a while. Not going to leave an HTTP connection open for something like that. The other common ones that you probably want to deal with, client error status codes, 400 bad requests, right? So fundamentally this means you've gotten some sort of bad syntax. So a great example is I might have put the wrong value in. What did I say? Started or something, or no, I put status in. And the client should interpret a 400 coming back to it as do not repeat this without modifications. Never going to work, just stop trying. 401, unauthorized. We're not going to do security in here right now, but this is basically if you get to an API that's secured, maybe to put a plug-in with Spring Security or something like that, that you have not properly authenticated against. That's horrible, right? Unauthorized, unauthenticated, two completely different things, but that's what they mean. It will hand back sort of the server is expected to hand back a header saying you need to authenticate, here are the ways you can do it, basic digest, blah, 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 kind of thing. So another piece of communication. Without looking a whole lot into it, you've communicated exactly what went wrong to the user and exactly how they can fix it. 403, forbidden. What you sent me, I totally get what you said, but I'm not doing that. No way, right? Don't repeat this without modification because I'm not doing what you just asked me to. 404, we're all familiar with this from using web browsers. You asked me for a resource matching a particular URI, so the example we just saw, right? Asking for a game that doesn't exist. We'll also see asking for a door that doesn't exist. Probably want a not found there. 406, not acceptable, which came up a little bit earlier as well. Server can only return a response for entities that don't match the client's accept header. So you asked me for XML, but I can't make XML, so I'm going to give you a 406. And 409, which is one of my favorite overlooked ones, conflict. Resources in a state that might conflict with the request. So for example, if we've got a door that's already open and you ask to open it again, the best choice there, conflict, right? It's not currently in a state that you can do this. You can attempt to rectify it. There's no guarantee you can, but you might be able to rectify whatever this conflict is and then have another go. So how do we handle exceptions? There are a number of ways to handle exceptions in Spring MVC specifically. I know just earlier this week I was sitting in some preview of some stuff that's coming in Spring 3.2 and learned 2 new ways that we're going to be able to handle exceptions, but we'll just do a simple one for today. And fundamentally what that is inside of a controller you can define an exception handler. So why don't we go with a response entity. I'm going to say this is string. Don't anybody ask me why yet. What happens, we want to handle what happens when a bunch of things haven't been found. Now, this method, we're going to see that it's annotated, basically has a lot of sort of the same possibilities that Spring MVC controller method does, or request handler method, where you can return a whole bunch of different things. In this case, we're returning a response entity. You could return voids. You could return a bunch of bytes, a string of you name it. You can take a whole bunch of stuff in, but one of the things that it does actually hand you is the exception that you were choosing to get. Return. It might be sufficient to say that the status code that we want, anybody remember? Well, probably by the name of it, not found. Something like that. And the way you mark this is you say exception handler, method like that. And inside of this, you could say the exceptions you want to be handled by this particular method. So maybe a game does not exist exception. But you could do more, right? Did I go back and forth depending on the number of exceptions that I actually have to handle? Sometimes I do sort of a method per exception, especially if you want sort of different behavior for the exception handling. In our case, we're going to do exactly the same thing. Excuse me. So I might say more than one. If either of those are thrown from outside of my code base, I want to do this. Now, let's go ahead and run this. We'll go ahead and do a demo and sort of demonstrate some stuff. Yeah, so if you slap add exception handler on it, I'm sure there's, judging by the number of Spring employees in here, they can correct me if I'm wrong. If you do add exception handler with no classes, it'll handle all classes. Sound right? Anybody want to correct me on that? We'll go with that then. Yeah, add exception handler handles them all. Yeah, sure, yeah, base controller class method. There are ways to define exception handler classes just sort of not in the controller at all. A class that is just a bean that knows how to handle them all. Is that what you were going to say, Rawson? Say again? An exception in the method signature? Yeah, so but you could have a big E exception or something like that. Or in the annotation, yeah. So you need to define big E exception somewhere, basically. Did you just look at the code to fork that out? So this time what happens? If we see before, what we saw was we had gotten a 500 internal service error when we asked for a game that didn't exist. That's not right. I mean, that's kind of the bucket where all exceptions go to die, but we want something better than that. This time we get a 404 not found, so we're doing better, but we still have all this HTML crap. It's not particularly descriptive to our users what's happened. So if we go back here, we can do something better than that. Maybe we do this. Really doesn't like, no, that's not what I'm saying. No, seriously. Thank you, Eclipse. There we go. I actually have to do real JSON in here. And so make sure I get all those right. Maybe say reason. And ask it for the message. Boom. So now, not only have they gotten a not found, we can tell them exactly what wasn't found, right? Game 42 does not exist. If we had, for example, game 0 and we asked for door 4, maybe the error message coming out of that exception tells them that door 4 doesn't exist, but game 0 does, or something like that. So that's how you do some exception handling, and you actually pass on a lot more information this way. Remember, just because you haven't gotten a 200 doesn't mean you can't return a body with some other additional information. This is, again, stepping beyond what a lot of people actually realize you can do with this stuff. Don't do what I'm doing. Do not copy and paste code under any circumstances. What do we have? Bad request is next. I have no idea. Missing key and illegal argument. Are you able to do a response body if the, yeah, absolutely, right? Because we've returned this response entity, all of Spring's normal marshalling and the entire tool chain that Spring would do for a normal response entity will be kicking in. So yes, if you had an exception that was Jackson serializable, sure, just return that instead, sure, yeah. That's actually, it's a good question, that's what we do in BAS, in fact. And one more, conflicts for the illegal transition exception. There we go. Conflicts. And so that's kind of it. Okay? So, we'll go ahead and kick this off because I want to show you one more thing. Anybody know how much longer we have? About 25 minutes? So we've created one of these, follow to 0. Go ahead and do a get. Great, exactly what we saw before. There's a problem here, right? I know, because I designed this API, that I now need /doors/ one of those IDs up there. But that's not something your consumers are going to know, right? There are a number of reasons why you don't want them to know it, primarily because you want a single entry point, and if you never define what those URIs are, if you never tell them what they are, you can change them at will. It's pretty nice, right? Imagine an API that has to meet contracts but doesn't actually have to have the same names, right? That's basically what we're talking about. So, what do we do? I hope that was the transition. The next slide will tell us. What is this word that there is no official pronunciation for? I'm going to go with hatos. I kind of think it's like Cheerios, only hateful. Hypermedia as the engine of application state. That is quite a mouthful, especially, I mean, the use of the word hypermedia. That's better than normal media, right? Are 3D movies hypermedia? Fundamentally, what this says is the client shouldn't have to have built-in knowledge of how to navigate and manipulate the model, right? Instead, it shouldn't have to have a map to all of your URLs. You shouldn't have to define to them, if you want doors, you need to know the ID of the door, and you need to know the ID of the game, and then you need to put them in this particular URI scheme. Instead, what you want to say is, as a server, I will provide you all the information you need to know dynamically so that you can traverse and manipulate as you see fit. I will give you a map to the next step, right? Choose your own adventure kind of thing. But you don't have to know what that is. I'll use some keywords to help you. But just assume that the URLs that I'm going to give you are a black box. And we implement this in HTTP using links in various different languages. I'm sure everybody's, we'll get back to links in a second. Forgot about this one. The other bit of Hatos is this idea of media types, specifically hypermedia types. We talked about when I do a get on a resource, what I get back is not the resource, right? I'm not shipping you a door via HTTP. What I'm shipping you is a representation of the door. So when we talk about media types, we're saying this door can be represented in different ways. It might be represented in JSON. It might be represented in XML. And most importantly, the client doesn't really know what the server is planning on sending it. You sort of assume that they have no internal knowledge of your particular design. How about this? A server doesn't even know what a client can handle generally, right? You have to assume that you might be called by a browser, called by REST template, called by requests if you're in Python or something like that. And so we do this thing called content negotiation. And that content negotiation in HTTP is done using headers. Client describes what it's willing to accept. So we have an accept header, and you put some stuff in there. You say, I can accept application JSON, I can accept text XML. Server and the client, in the case of the post and put, also describes for whoever the consumer is what it's sending by saying, you've told me you can accept all of these things, and I've selected out of them this. And that's what you put in your content type header. So everybody's sort of used to seeing this when you do a get on a server. The server tells you the content type. But it turns out it's quite useful when you're posting something to say, I am posting you application JSON, so that the server doesn't have to sort of poke around and scan and say, oh, are you JSON? No, you're not JSON. Are you XML? No. You tell it what you're planning on sending. The other half, link relations. A client can't be expected to know what a resource is related to and where those relations are located, right? What those URIs are. As a client or as a consumer, as we saw in the REST shell, I don't know what the URIs of those doors are. More important, I mean, I don't now. And certainly the people you are trying to target with a REST API won't know either. So we use this thing called links, right? Link is sort of an abstract statement. It happens to be very concrete. Everybody knows sort of link rel style sheet href. So a rel is sort of the relation keyword, and href is the universal identifier, the URI, for the thing that you are describing a relation to. Because the idea of a link is sort of a very abstract thing. It can be represented in different ways, and so you see it often represented inside of JSON as a dictionary like that with a rel and an href as well. rel values. So what we've been saying is you don't publicize your entire URI space because it gives you the ability to change as you see fit. If you want to go from something that's a deeply nested structure to something that's completely flat, where every type, even though there might be an inheritance hierarchy between these objects, logically, it doesn't necessarily have to be that way in your URI space. Maybe you make that change and maybe you decide, no, this is crap. This really isn't good. I need to get some more information from the URI. Let me move it back. You can do that. You can change your URI scheme at will. However, and this is what's key, you can't change your rels, right? The rels become the contract. To get a style sheet, this is where you go. To find the doors, this is where you go. So you standardize. Top one is truly standard. The bottom one is standard in the context of my API. So we've got a project called Spring Hatos. So Spring Hatos makes it very, very easy to sort of start attaching these links to your code. Now, what do we want to do first? Links themselves are sort of a web tier, presentation tier kind of concern. So in general, we don't want to be polluting our domain objects with this kind of stuff, right? I don't want my door object, I don't want my game object to have links associated with them, mostly because they have URIs, and at that level, URIs don't make any sense. So at the moment, what we do with Spring Hatos is we create these resources, and they're basically just throwaway objects, sort of wrappers around or sort of approximations of our domain objects that expose exactly the things we want, but they also extend this resource support class. It actually is a support class for a particular interface, but the key here is it gives you a bunch of methods. There's no way you guys are going to see that, about dealing with links. So how you add a link, how that you get all of the links and things like that. And if you take a look at sort of the support class, it has all the annotations on it. Let's see if my source code is mounted properly. It has annotations on it for doing JAXB mapping and Jackson mapping as well, for representing this stuff. So we've got this door resource. Is that the only one I need to do? Oh, no, I actually need to do a game resource as well. So we've got a game resource that only returns its status. So let's take a look at how we create one of these, right? So we have one of these game resources, and we could new it up, set the status, add a bunch of links to it using those methods. But realistically, we need to do this in a whole bunch of different places. So why instead don't we simply go create an assembler, more or less a factory? So there is a class called, or a base class called Resource Assembler Support, and it exposes primarily this method to resource. Given a game, how do I convert it into a game resource? Internally, it has a lot of really helpful things, such as it will automatically, for example, create a self-link for you. And we'll talk a little bit about the different link types that we expect to see. Game resource. So a little helper thing that knows how to use reflection to instantiate one of my game resources. I'll set the status that I actually want to be represented. And now I'm going to add one of those links. And this is the link 2 that we saw a little earlier. Excuse me. That comes from Spring Hatos. And so in this case, we're going to say it's games controller. Knows how to read the request mapping stuff. We say dot slash, we've already got slash game. So as part of the controller, so now we do slash game.getID, so slash games, dot slash doors. And we want to, since we're adding a link sort of in line here, we need to give it a rel. And so in this case, we're going to say doors. Okay? And then we'll go ahead and return this guy. And we'll go ahead and do the same thing on the doors as well. I'm sure there's something else that's still red in here. Door resource assembler. You'll notice in this particular case, I've written one of these resource assemblers, but I have not extended the resource assembler support class. Why? Because I need a bit more information in this particular case to be able to properly create a door. To create a door resource. It's not sufficient for me to be given the door simply because my domain model is unidirectional. Games know about doors, doors don't know about games, so I need the game as well. The caller of this is expected to be able to have both of those. We know we have the game ID and can retrieve it. We know we have the door ID and we can retrieve that as well and pass it in. So the key is the resource assembler is sort of more a logical construct rather than sort of a mandatory type construct here. Sorry. Now we need to add a link here, link 2. Because we are not using the resource support class, we are responsible for creating our own self-link. And again, once we sort of get this displayed on the screen, I'll talk a little bit more about those kinds of things. ./door.getID. Isn't it? There's a shortcut for this, isn't there? Give me a second. Am I in the wrong set of parens? Oh, yep, I need to do the import. Thanks, everybody. With self-rel. There we go. Self-links are so important that there's a shortcut for it. So now, if we go back, we say, where's my controller here? Instead of returning a game this time, instead what we actually want to return is a game resource. Resource equals this dot game resource assembler dot 2. And then return that guy instead. There's one for a door. I think that'll be it. Oh, yeah, thanks. Yeah, okay. So let's see what happens if we run that. Yeah. So this representation is a bit different. Move that up for everybody. This representation is a bit different. Certainly there's a lot less stuff, right? The IDs haven't shown up in here. The doors haven't shown up in here. All we know is the status of the particular game. But what has shown up in here is this collection of links. And as we said earlier, we want to use links to actually traverse to find things. So one of the first links that we see there, the self-link. In general, it's considered a very, very good practice, although nobody's wrong, to make sure that you have a link that is the canonical representation of you. So it is quite possible for me to make a request via HTTP, right, to a URI that is an alias for another object. So a self-link helps, I suspect for most of us, in 99% of cases, the self-link will always be the link that was just requested, but it's not necessarily required to be. So having a canonical representation of who you are is generally considered a really, really good idea. The second one is the interesting thing, right? is this doors link. Again, that is our standard that tells us how to go find the listing of doors. And unless I've forgotten a piece of code in here somewhere, which is certainly reasonably possible, REST shell has a command called discover. Has a command called discover that is actually supposed to go and find all this information out for you. However, it's telling me 406 not acceptable. Anybody remember what not acceptable means typically? It means the content type that you want to get back is not something that I've said that I can give you, right? So in this particular case, the reason behind that is because we haven't told it that we'll even accept JSON. So headers, set, name, accept, value, application JSON. I think this is it. Work for me. Yeah, there we go. Get a nice little representation there of all of the links that happen to be associated in here. So we can now just simply say, I want you to follow doors. If the rel was different, we'd see something else. So if we go down to doors now, we see an interesting representation here. I go so far as to say this is pretty non-standard, the way most REST interfaces are currently defined, in that when I asked for all of the doors, most things, including REST shell at the moment, but I will make sure that this ends up as an issue to get changed, expect an array to come back, an array of doors, right? So basically everything inside of the, see about 5 lines down where doors starts there, right? Basically, if you unwrapped the object from around that, that's what it actually expects. And in that case, we actually have a representation of doors. Each door has a status, it has a content, and inside of it, it has links. So links inside of links, effectively, that represents what itself is. So this would be the unique identifier. This is how I know what door. When it comes time to put back the change to the door, that's the URI that I used. I don't know what that scheme is. It's just given to me sort of as an opaque black box that I go ahead and call at. But what we've done here, and this is the part that I think is non-standard, but I think is really, really honestly the way this should be done, is we've wrapped this whole thing in an object so that we can give even the doors object, or the doors resource, links as well. In this case, particularly a self-link. But you could go beyond that, right? Suppose, for example, we had 10 million doors, right? I don't want to actually return you a list of all of them, so I might paginate it instead. And so I give you the first 100 doors, and then there are links. There's a self-link, as there always should be, but then there's a next link, last link, first link that points to different URLs that describe how to get around in this pagination scheme. No one needs to know what those are. If you implement them, as earlier suggested, with request parameters on the gets, for example, maybe that's in there. If you have completely separate URIs in some other way, a whole lot of slashes, the matrix variables or something, maybe that's the way you've done it. But the user never needs to know that. And that's the beauty of using links, right? So any questions about that kind of stuff? Yeah. Yep. Yeah. Yeah, so the answer is a lot of the stuff sitting near the front of this all comes out of Spring's infrastructure. So Spring knows sort of what the request URI actually was. And so if you use sort of the link to that whole system inside of Spring HATOS, we basically go and look at what Spring thinks the request actually was to get a lot of that information, including like the context path and stuff like that. But you are free to do anything you want. I know recently put into Spring HATOS was some functionality around massaging that. So it doesn't always go look at Spring stuff. So if you know, for example, that requests can come on one IP address or one host name, but you want the canonical representation to go back as a different host name, you have the ability to configure that. If it isn't obviously suitable for what you want, Spring HATOS is a young project with not a whole lot of committers on it. I'm sure patches and pull requests are certainly appreciated, and if not those, then certainly issues driving features. Yeah.
I have a question. For my client developer, do I need to give him a jar containing all the resources? Otherwise, how he will know what to send in case of create?
Documentation. The answer is always, always, always documentation. Just because this is flexible, just because this doesn't have WSDL and some sort of well-defined code-level contract, for lack of a better term, doesn't mean that it's not incredibly structured, right? As you point out, the messages that come and go, you absolutely need to document what those are going to be. But it's just, it's just documentation like anything else, documenting an API. What you expect to come in, what you expect to be returned, what exception cases there might be, all that kind of stuff. They don't need to know what the URLs are. They do need to know other stuff, yeah.
How to handle API changes? API roles, let's say.
Yeah. Yeah, and the answer is fundamentally, hopefully, those kinds of things are hidden behind this use of links, right? The URI scheme can evolve as you see fit without a huge amount of work, as long as you're sort of keeping the rels the same. When it comes to API versioning and things like that, there's a lot of interesting discussions. Definitely grab me after this, and we'll talk a little bit about that a little more. That is less well defined what the proper answer is. Yeah. Yeah.
How do you design a REST URL for looking at a view of an object? Let's say I want to read the icons. Wishful thinking. So you have a song, you have some song title, singer, producer, whatever.
Yeah.
That is one set of information. The actual lyrics itself is another set of information.
Mm.
Then you have the actual media, the third piece of information.
Yeah.
Let's say I just want to look at the list of only the song credits.
Yeah.
So if I want to just get a portion of the object, but a collection, how would you design your URL for that?
We're running out of time quickly, so just grab me after this. We'll do a quick bit because I want to talk a little bit about testing. We're not going to do a huge amount on this. I will immediately put in a plug. Rawson over there is doing a talk tomorrow, second session tomorrow in this room about the testing stuff that we're going to talk about. Fundamentally, testing these web APIs isn't easy. You can test in the container, maybe do end-to-end, full end-to-end test, including your service layer, string comparisons of the things that you get back. Out of the container, you might do Java objects, but you're not really doing a lot of Spring's magic, right? Think of how much Spring MVC does today, whether it's exception mapping and handling, whether it's type conversion from various JSON, XML, whatever. What we want is to get out of the container, right? So that we don't have sort of the overhead and we don't have to do a full end-to-end test necessarily, but we still want a lot of Spring attached to it. So coming in Spring 3.2, it's in the snapshots today, bootstraps most of Spring's MVC infrastructure for you so that you can both unit and integration test your web application end-to-end, let's call it the web layer, the web tier of your application end-to-end if you want to do it that way, or potentially the full end-to-end. And it provides APIs for testing interesting parts of requests and responses. And since I have done a bad thing and run out of time, I am going to shortcut this. Come on. Gotta love Git. That's fine. I actually broken this. No. Yeah. So fundamentally, in Spring 3.2, what we've come back with is this mock MVC thing here. And it basically allows you to set up a Spring application context, but more importantly, sort of the Spring web tier. In this case, we're basically doing a standalone kind of setup saying that what we want to do is instantiate one of these games controllers. And in this case, we're injecting a bunch of stuff, but most importantly, we're actually injecting a mock at the game repository so that we don't have to go all the way back into our service tier. And then we want to run some tests about that. It's not simply sufficient to say new games controller and run, execute the methods directly. I want to actually do gets. I want to actually do posts. I want to actually take a look at the JSON that has come back from this. And so you find out that you can do things like this. So when we went to show the game, I want to perform a GET based on a particular location, telling it that I will accept a media type of application JSON. And when it comes back, I expect the status to be okay. There's something here called JSON path. I know a lot of people aren't particularly familiar with this, but basically it's an analog to XPath, but for JSON. So in this particular case, I can say take an object, look inside of links wherever the links equals self, take a look at the href on that, and make sure that it is game's location. When it comes to doors, I want to take a look inside the links, take a look at the doors, href, make sure that it ends with doors. It's the game location plus doors. And there's all sorts of stuff that you can do. You can assert, for example, in this case, there was an exception, right? So we can do great exception testing here to test our @exception handler methods. When somebody asks for a particular game, to remove a particular game in this case, we want to throw an exception. We want to assert that the status is what we had expected to be, not found, and that the content inside of it, the body inside of it, is game 0 does not exist. Make sure now we can say, are our exception messages proper? Imagine if you wanted to do some localization on these exception messages, right? You could do that and you could test it really, really easy to make sure that the messages, the bodies that are going back to your users are what you think they are. And obviously the JSON path can get really, really extensive. You can use Hamcrest matcher, so you can say that the thing that is returned is a collection with a given size. You can say, take a look inside of this line, where the hell is my cursor? Down here in the doors. We can take a look into all of the doors, take a look at all of the self links for the doors, make sure they are door 1, door 2, door 3. So again, I apologize for having to rush through that. It's my bad. Definitely go see Rawson if you're interested in this. Probably one of the biggest time savers that we've found when working with REST APIs. I would tell you, we'll go ahead and skip this. This was where I was going to show you my amazing Python skills. We've designed, implemented, and tested this API. Can it work? The whole point of REST APIs is anybody can use them, right? You could use REST template to test this. You could do something a little bit more interesting in that you could write Python on it. You could write Ruby on it, something like that. All of this code's checked in. There's a URL that I'm going to post up here. So if you are truly interested in it, you can take a look at the Python code and see how we just traverse links inside of it so that we can find out where all the doors are and stuff like that, and do content negotiation, make sure we're getting that kind of stuff. So roundup, API design absolutely matters. Probably the biggest overlooked thing, I think, when it comes to REST is it's not sufficient to say, I have doors. Here's an API for doors. I have games. Really, really want to put some time into understanding the user interaction model. Make sure that your URIs represent nouns, right? URIs are the things that need to handle the request, not the things that are happening. The things that are happening are those verbs. But remember that you can use those simple number of verbs to do almost anything. You just have to think about the problem differently than you might initially do. Implementation isn't rocket science. Spring MVC. Everything I showed you has been around since, I'm pretty sure, like the very beginning of Spring 3, right? It's not coming in 3.2 or anything like that until you get to the testing stuff. Spring HATOS, obviously another project that's out there. It's gotten quite a lot of plugs this week at Spring 1. It's a really, really big deal. HATOS in general is really starting to come to the forefront of REST now to be what it means to be RESTful is certainly a continuum, but it's even an evolving continuum. What to be RESTful a year ago is very different than what is sort of accepted to be RESTful today, and what's accepted to be RESTful today is definitely using HATOS. And easy testing, out of the container, but still using the full Spring stack is what Rawson's going to bring to the table. So that's it. There's a URL, pretty easy, just on GitHub. I think you're seeing that quite a bit from the other presenters as well. Thank you all for being here. I apologize for keeping you a little bit longer. Anybody who wants to talk, please meet me up here for about the next 10 minutes, and then I'll clear out, and we can meet out there if you need to. Thank you, everybody.